Okay, so those of you who are at home, what you will need to do is I'm going to show you. You're not going to watch this video first because this is going to be the answers to the questions that you're going to be doing. So what I'm going to need you to do is I need you to go to your project Lead the Way, which I'm going to present my screen to show you how to get there. So what you're going to do is go to horrycountyschools.net. You're going to go to your project Lead the Way. You're going to go to My Project Lead the Way. And on here, you're going to go into your class. You're going to go over here and you're going to go down to 1.2. And we're going to scroll down to where our assignment is today. And as you can see, that activity 1.25, the VEX is what you did in class this week. So now what you're going to do is you're going to go to 1.2.5 cent. So when you open this up, it's going to give you some information about energy conservation, like we talked about yesterday. It's also going to give you a formula for efficiency percentage, which is your power out divided by your power in times 100. And then what it's going to do is it's going to give you data. So this is going to be your data that you're going to be using from an ATV winch, like the one you built. And what you're going to do here is you're going to go in here and you're going to do the work for each one of these forces. So you have force 0, you have force 7,000 and 11,000. You're going to go in and put that, multiply it by your D, which is your distance, to get your answers. Now, in this section right here, what I would like you to do is I would like to have you copy that in your ISM book. And so you're going to have one for each one. So then when you go down, you're going to see the one for power out, which is W out over T. Well, we just figured out what W out was, which was up here, and we're going to divide that by our time to find that answer. Then we're going to do our power in, which is our I times our V for each of the three, and then you're going to find me efficiencies. When you get done with that, you will need to answer these 4 conclusion questions. So and that's what you're supposed to be doing today. So once you get that done, then I need you to come back to the video that I'm recording now, and you will need to come here and check your answers and make sure that your answers are correct. So if you would please just go ahead and get out of this meeting, go do that, and then I will have it recorded probably about an hour. And then what you're going to do is you're going to come back in here, and I'm going to have the answers right behind me on my board here. We're going to go over it in class. So if you didn't understand it or how I got the answer, then you can watch this to do that. Okay. All right. So Monday and Tuesday, we talked about work and what work was. And what we talked about with this work is going to be the letter W. And if you remember, when we're talking about work, we're going to calculate that into joules. To be able to get joules, we have to have newtons times meters. Most of the time, when you're doing work, you're going to have it in pounds per foot. So what you're going to have to do is you're going to have to do a conversion. Remember on Monday, if you watched the video, we had a problem. And what we did with that problem is we took pounds per feet, we changed it to newtons per meter to find how much work it was. Energy is the ability to do work. There is light, heat, mechanical, chemical, electrical, which actually causes a force to go and send that in a distance. Then you have potential and kinetic energy. Potential energy is like stored energy. It's like a battery. A battery is ready to go, but it's not going to be used until you hook it up. Same thing with kinetic energy, is something that's actually moving around. We have how you transform this energy, and we talked about that a little bit yesterday, on how these things, when we're talking about matter cannot be created nor destroyed. Since it cannot, it changes from one form to another. If I took a piece of paper and I tore it into 1,000 pieces and put it on the ground, if you went and got every single piece back and taped it back, it would still be there. So the examples were the fossil fuels, the solar cells, wind turbines, hydraulics, and nuclear, and we talked about that yesterday. Here's where we were talking about our efficiency. Efficiency, when we're talking about this, is in the letter N. When we're talking about that, we're talking about the energy out by the energy in times 100. That's what we did down here at the bottom, is we went and we found our efficiency. Power is the rate of electricity that extends or work is performed over time. So to be able to find that, you have to have work first. Type of power, and then today is where we're just going to put it all together. So on the computer, you had information, you had numbers, okay? And what we had is we had 3 scenarios of 3 different forces. We had distance, time, current, and voltage. So the first thing that it wanted to do is it wanted to know what work was done on each one of these systems. To be able to do that, only thing you're going to do is take your force times your distance. And that's what we did here. We did that to find this final answer here, which is going to tell us how much work each one of those 3 scenarios did. We have to find work first, because to be able to do that, to find power out and power in, we're going to have the work. We're going to have these numbers down here to be able to do that. So what we're doing here is we're taking the answer we got here from work, and we're dividing it by the time. So we're just going here, we're dividing these two to give us what the power out was. I would like you to get your computers, please, and open them up, and we're going to do these other 2 here. Answer why. How did I get the work for the third one?
Because your math is 7,000 times 24, and then
Here?
Yep.
Okay, I'll check it.
264. That's where I got
Is that what you got?
Yes, ma'am.
Sorry. Yes, you're exactly right. Only have to have one today. Wouldn't be the same number. That would make sense. Oh, that's too bad. Thank you, sir. 264,000, correct?
Yes, ma'am.
Thank God. So now we can fix this one too. 264,000. Okay. So let's get our calculators out. Have you got that far? Did you get that far on your work, the ones that did it? Okay.
I got all of it.
You got all of it. I know you did it Monday. So if we take 16,800 and we divide that by 36 seconds, what do we get?
166.67.
Okay. Okay. So the next one is
466, not 43. This is 361.
well, I took this number and divided by that one. Oh, never mind. God bless. One of these days. There we go. Thank you, sir. Okay. So let me see if I can do the next one. You get 366? Fantastic. Okay.
Are y'all
So,
rounding the answers?
ma'am,
Are y'all rounding the answers? Because with some of them, I was getting them in like the thousands. So
yes,
it's
ma'am.
gonna be a decimal.
Yeah, and if you put the whole thing out, it's fine.
Okay,
It's
I
all
did.
going to work back out at the end, Jess.
Okay,
All right, baby?
all right.
So then once we go ahead and get our power out, how do we get our power in? Where are we getting this number? This I stands for what? Current. So we're taking our 15 amps and we're multiplying it by our voltage, right? Our voltage is 12, so that's 180 watts. That one is 1,200 watts, and that is 19,200. Let's see what that is.
1,920.
Times 12. Yes, 1920. I'm good. Watts. And then the only thing else we have left to do is find out our efficiency. And to be able to get our efficiency, we have to take our power out, which is this number here, and we're going to divide it by our power in here. And then once we get our number, we're going to multiply by 100 to get our percentage. Jesse, did you get all those answers, baby?
I just got home from the hospital.
Okay. Well, do me a favor, get off of here. Go back to the thing and finish it. And then I'm going to post this with the answers so you can make sure you're doing it right.
Okay.
All right. Thank you, baby. And you too, Kate.
Okay.
All right.
Good luck. If you want to, just go ahead and put it in there. Have you and your partner played your video? And that it? I'll go ahead and start thinking about that real quick. All right, guys, that's the end of this today. So just go ahead and make sure that you check your answers. Make sure you go back on for tomorrow. The question that I'm going to ask you today is going to be, if we have a distance, so I'm going to have another problem for you to do. So we're going to have force, we're going to have distance, we're going to have time, current, and unit. So I'm going to say it's 760 newtons is my force. My distance is going to be 24 meters. My time is going to be 60 seconds. My current is going to be 12 amps. And my volts are going to be 12 volts. And what I would like you to do is I would like you to tell me what the work done is, the power out is, the power in is, and the efficiency. So if you can write that in your ISM book, and you can take a picture of that and attach it to the question of the day. Thank you.